What's up, Algebra 1? All right, so here's some examples for this lesson that you're being assigned today. So let's go ahead and jump right into it. So this is going to be solving system of equations in which there are fractional coefficients, okay? We're also going to look at some that have decimal coefficients, and there's a real easy way to deal with those. But what we want to do is, number one, we want to have everything in the form of ax plus by equals c, okay? And we don't want any of the coefficients to be fractions, and we don't want them to be decimals. We want to deal with whole numbers, okay? It's really easy when you get to that, and there's actually an easy way to get to that position where you're working with whole numbers if you don't already have them, such as the case here. So first of all, we're going to go ahead and clear. What we want to do is we want to clear this top equation of that fraction. I think we've gone over this, and so what we're going to do in this case, it's easy. There's only one fraction, so we're just going to multiply everything in this equation by the denominator, right? So if we want to get rid of that 3 in the denominator, we're just going to multiply that by 3, and whatever I multiply this by, I have to multiply everything by. So 3 here and 3 here. So I'm going to rewrite what we have here. I'm going to bring all this down here, right? So it's going to give us 3y equals, okay, that's going to cancel. So it leaves me with 2x, and then negative 6 times 3 is negative 18, okay? All right, so that was all of this just came from this first equation, and all we've done is just we've cleared the equation of the fraction there. All right, but we still have some work to do. We still want to put it in the form of something x plus something y equals something, right? So let's go ahead and move this 2x over here. Whoops. So it's going to give us, that's going to cancel. It's going to leave us with negative 2x plus 3y equals negative 18. And then I'm going to go ahead and bring this second equation right below it. So 2x plus y equals negative 2. All right, now at this point, we've looked at, I think, three different ways that we can solve systems of equations that have two variables. Okay, we've talked about the substitution method, where maybe we would subtract x from both sides on this bottom equation. That would leave us with y equals negative 2x minus 2. And then we would plug in negative 2x minus 2 for this x up here. So you can use the substitution method. You can use the addition, also known as the elimination method, or you can use the matrix method. Now, for me personally, I'm just going to show you how I would do this problem. The easiest way that I see is just to use the addition method, because I already have a negative 2 and a 2 that cancel right here. So if we do the addition method where we add everything here, then those cancel out, and that leaves me with 4y equals negative 20. And then I divide both sides by 4, and it gives me y equals negative 5. Okay, so I know that at least part of my answer, if I write my answer as an ordered pair, my y value is negative 5, and then I'm just going to take negative 5 and plug it back in to one of these equations. So I'm going to plug it back into this bottom equation. So that's the original equation here. It was 2x plus, okay, now instead of putting y here, I'm going to put in negative 5 equals negative 2. All right, does it make sense? All right, now that's actually 2x minus 5 equals negative 2. I'm going to add 5 to both sides, and I've got 2x equals 3. Divide here, and x equals 3 over 2. Okay, or 1 and 1/2. So I'm just going to put 3 over 2. Okay, so that's how we deal with that. All right, let's look at another example. Okay, now here, this is actually number 6. And I think they're going to give you some options. Okay, which equation is equivalent to this? All right, so what they're using this for is just to show you now how do you clear an equation of the fractions if there's two different fractions? Okay, so it's not going to do it. It's not enough to just multiply everything by 2 or everything by 4. All right, so actually it is going to work to multiply everything by 4. So what do you do when you have two different fractions in the equation? Okay, you're going to multiply everything in the equation by the least common denominator of these two fractions. So in other words, if for example we were adding, let me pull this piece of paper here. If we were adding 1/4 plus 1/2, okay, what would your least common denominator be? Right, it'd be 4, right? That would be 2. That'd be 1. So it'd be 3/4. Okay, so we figured out what our least common denominator is. All right, so that's what we're going to do here. Our least common denominator is 4. So whenever you have two different fractions in the equation and you want to clear the equation of all the fractions, you multiply every term by the least common denominator. So in this case, we're going to multiply everything by 4. Okay, and what does that give us? Well, over here, those cancel, so it leaves me with x, right? Over here, that reduces down to 2. Okay, and then 2 times negative 1y gives me negative 2y. And then 8 times 4 over here gives me 32. Okay, so that's how we would clear any equation that has more than two fractions. Now, you're going to see, I think it's in number 7, don't quote me on that, but I think it's number 7 where they're going to actually give you two equations. You're going to have an equation like this that has more than one fraction. They're going to have a second equation that has more than one fraction. So what you're going to need to do is you're going to need to clear the first equation of all the fractions by multiplying every term by the least common denominator, and then you're going to do the same thing to the second system of equations. You're going to multiply everything by the least common denominator, and then once you get the two equations in this form, then you can just choose whichever way you want to solve. If you want to use the elimination method, if you want to use the matrix method, if you want to use the substitution method. Okay. All right. Let's look at one more example. All right. Now, how do we deal with situations where we have these decimals like this? Okay, this is actually really easy. So if I want to get rid of these decimals and just make these whole numbers, I'm just gonna multiply everything by 10. All right, because if I just move this decimal place 1 to the right, that makes that 5. If I move this 1 to the right, that makes that 2. Okay, so what am I doing when I move a decimal 1 place to the right? That's actually the same thing as multiplying by 10. Okay, so if I multiply everything, I'm going to do it a little bit different way. If I multiply everything here by 10, then I'm going to rewrite what I have done here. That's going to give me 5x plus 2y equals 30. So notice that whatever I do to one term, I'm doing to every term, right? Okay, and then I have x plus y equals 9. All right, now there's several options that you could use to solve this. All right, my personal favorite way is just the addition method. To me that's the easiest way. So think with me here. What could we do to this bottom equation so that when we add these together, it causes one of the variables to cancel out? Okay, there's actually two things you could do. You could either multiply everything in the bottom equation by -5, or you can multiply, and if I do that, what variable will I cancel out if I multiply everything by -5? That's right, it'll cancel out my x. And remember, that's what we want to do. Whenever we have two variables, right here, I can't solve. If I have two variables, I can't solve. But if I reduce this down to one variable, then I can solve. All right, and if I multiply by -2, then I cancel out my y. So I'm going to do that. I'm going to multiply everything in the bottom by -2. So I'm just going to rewrite the top equation, 5x plus 2y equals 30. Okay, haven't changed anything there. But I'm gonna rewrite everything in the bottom equation multiplied by -2. So that's going to give me -2x minus 2y equals -18. Okay, so I just multiplied everything by -2 because I want this right here. I want that right there. Because why? Because it's going to cause these two to cancel. All right. So now we're just going to add. Okay, in this case, it's going to be subtract. Okay. So that 5x plus -2x is the same thing as 5x minus 2x. That leaves me with 3x. Okay. These cancel out. Equals 12. X equals 4, right? Because we divided both sides by 3. Okay, now I'm going to take my 4, and I'm just going to plug it into. I'm going to come back to I'm just going to come up to this one right here. Let's plug it in right there. We can do either one of them. Matter of fact, we could even do it. We could even plug it in right here. That's maybe even easier. So let's go with this one right here. X plus y equals 9. So let's plug in 4 for x. So we'll go 4 plus y equals 9. 4 plus y equals 9. Subtract 4. Subtract 4. Oh, hang on a second. When we do that, the 4's cancel. Y equals, what does y equal? Y equals, okay, 9 minus 4 is 5. And I can plug those in and double check my work. So x is 4, so 4 plus 5 is 9. And then let's try it up here. So 4, so if I plug in 4 for x here, that gives me 20, because 5 times 4 is 20. If I plug in 5 for y, okay, 2 times 5 is 10. 20 plus 10 is 30, so 30 equals 30. That's correct. Okay, I hope this helps. Let me know if you have any questions. Okay, again, just real quick, the way we clear an equation of the fractions, if there's more than one fraction, what do? We multiply every term. We have to first determine what's the least common denominator. Then we're going to multiply every term by that least common denominator, and that's going to clear the equation of fractions. So clear the equation of all the fractions. Make sure that both your equations are in the correct form, something x plus or minus something y equals something, and then choose an algebraic method, whether it be substitution, elimination, also known as addition, or the matrix method, and figure out your x and your y coordinates, which is going to be your final answer is going to be an ordered pair. And also, just to remind you, that ordered pair, remember, we can graph these lines if we put them in slope-intercept form. And if we put them in slope-intercept form, the point where these two lines intersect is the ordered pair that is your final answer. All right? Okay, have a great night.